In this lesson, we're going to have a quick look at logarithmic functions. This will be covered in more detail in Unit 3, but we briefly look at it in Unit 1. Now, up here we say until now we could only solve problems like x squared equals 64 and x cubed equals 27. You would square root or cube root that. But we haven't really looked at problems like this in mathematics. 5 to the power of what makes 125, or 2 to the power of what makes 32, and so on. This can be written as this. It takes a wee bit of getting used to. They used to use it in the olden days in mathematics, used to use log tables to do calculations, but we don't use that anymore. So the first introduction you get to logs are in higher maths, but this is the idea behind it. 5 to the power of what gives you 125? That would be the answer to this. That would be the value of y. 5 to the power of what gives 125? Now 5 times 5 times 5 makes 125, so that would be 3. So this is log 125 to the base 5. That's how that is said. Log of 125 to the base 5. If you look at some more examples, since 2 cubed is equal to 8, if we're trying to work an answer out to this, then 2 to the power of what makes 8? Well, it's 3. And so on. If we look at these examples here, 3 to the power of 4 is 81. 3 times 3 times 3 times 3. So, if we're looking at this and we're trying to get an answer, then 3 to the power of what makes 81? Well, it's 4. We know that from the exponential value here. And 5 squared is 25, so if we were to answer log, what is log 25 to the base 5? You think 5 to the power of what is 25? Well, it's 2. So each answer to a log is a power. 2, that would be 5 squared, wouldn't it? So the 2 would be a power. 3 to the power of 4 would be 81, so the answer is just a power. If you can get that into your head, it's much easier to work with. The answer to these questions are just powers. What does the graph look like? Well, the graph of logarithmic functions are the inverse of exponential functions, the exact opposite. So an exponential function always goes through 0, 1, and goes through 1a, the base. So the inverse of this type of function is a reflection in the y equals x. And it's easier to see in the next screen. You reflect in y equals x and you get your logarithmic function. Now, some important notes about the logarithmic function are these two values here. This value here, just like the exponential always goes through 0, 1, the logarithmic function always goes through 1, 0. It's easier to understand up here. It always passes through 1, 0, because if you look at x and y, if we said x is 1, and we had 2 to the power of what makes 1? Well, it must be 0. If we had a base of 3 here, 3 to the power of what makes 1? Again, it must be 0. So whenever you've got a value of 1 as x, the answer is always going to be 0. So that's always going to be through there. If you can't get your head around that, then if you think about the exponential function always going 0 through 0, 1, then the reflection is always going to go through 1, 0 if it's reflecting y equals x. The other main point that you need to look at is this value here. This is the graph of log x to the base 2, and it goes through 2, 1. If it was log x to the base 3, it would go through 3, 1, and so on. And if it was log x to the base 4, it would go through 4, 1. And here's the reason for that. If we have the value in this case of 2, 1, and we put a 2 here, and a 1 here, then if we're saying 2 to the power of what makes 2, then the answer is 1. If we had log x to the base 3, and we wanted an answer of 1 here, in the y value, then it would need to be 3 to the power of 1 makes 3. So that would have to be a 3, so it would be 3, 1, and so on. If it was a 4, then the x value would need to be a 4 to get an answer of 1. So it would always go through the base, really. So if that's a 2, this would be 2, 1. If that's a 3, that would be 3, 1, and so on. So when it comes to this kind of idea, what's the value of a here? Well, we can substitute this in, so that would be 3 there and a 1, and what to the power of 1 makes 3? It must be 3. Look at it down here. 3 to the power of 1 makes 3. Same idea over here, y equals log x to the base a, and it's going through 6, 1. So if that was a 6 and this needs to make a 1 here, then the a's got to be a 6, because 6 to the power 1 is 6.